Okay, in this video I want to show you what the graph of a Fourier series is going to look like. So this is the piecewise function from the last example. From negative pi to 0 it's a 0, and from 0 to pi it's pi minus x. So that's a straight line on the left and a diagonal line on the right. And this is the series we got in the former video for the Fourier series. The only thing that I've changed is I put an n instead of an infinity so that we can look at what happens as you add more and more terms to the series. So when I only have pi over 4, we have a constant function, but as soon as I add the first cosine and sine, suddenly we have wobbling shapes, and at least it's trying to look like the blue shape. Once I add another sine and cosine, so the next one would be cosine 2x and sine 2x with appropriate coefficients, it's going to start to look a little closer to the actual function. And as I let n increase and get bigger and bigger and bigger, you'll see that it does get closer and closer to the function it's supposed to be approximating, which is this blue shape, which is a diagonal line here and a horizontal line here. And so as the number of parts of the series increases, it's getting closer and closer. So realistically, n would be going to infinity, and so it would be the limit of this red shape as the number of n gets larger and larger. But there's something else to note about this shape, which is that not only is it approximating the function f of x, but it's also a periodic function. So if I zoom out, it's not just defined from negative pi to pi anymore. It's actually the same shape repeated over and over and over again. It's a periodic function. And the reason for that is that the function we started with, or the functions we started with, being constants, cosines, and sines, are all periodic, and all of them share the same period, even with the n and the pi and the p in there. All of them should share the period that goes from negative p to positive p. So cosine, regardless of the n, is going to have a period, meaning it's going to repeat from minus pi to positive pi. So whatever your shape is in the middle there, it's going to repeat over and over and over again. And so our limit of this function is approximately going to look like the original shape. However, we also have the same shape repeated over again. So our actual limit of the piecewise function is going to be a piecewise function with infinitely many steps that has 0 and then a diagonal line, 0 and then a diagonal line, 0 and then a diagonal line, and just keep going over and over and over again on both sides of the number line. What I did want to talk about, though, is that this red function is a sum of sines and cosines. It should be continuous, but the limit is a sum of infinitely many sines and cosines that may or may not be continuous. And so what it's going to do is it's going to try as close as possible to approximate this black shape, this periodic version of the original f of x. But it's not going to do a great job at these points of discontinuity. That's where I was showing you in the first video in this section. It's going to be the sum of the limit from the left and the limit from the right, or the average of the limit from the left and the limit from the right. So if I look at this particular spot, which apparently is negative 2 pi, from the right, we're approximately approaching height pi. From the left, we're approaching height 0. So halfway in between would be, halfway between 0 and pi would be pi over 2. And so the actual function that the Fourier series converges to, or the actual function that you could think of the infinite Fourier series with an infinity here is going to look like, is this periodic version of f of x with some extra dots. So we should have an open circle at the endpoint and a dot, and then another open circle. And again, the idea is the Fourier series is going to try its best to look like the original function, but if you have a discontinuity or a jump, you're going to have to approximate it. You're going to end up being, the Fourier series will be halfway in between the left endpoint and the right endpoint, what the function expects their heights to be.